Hey everybody, it's Miss Moyer here with a video on 12.1, Parallel Lines and Transversals. So I'm going to remind you of some things we did earlier this year. First, adjacent and vertical angles. Remember, adjacent angles are next to, and vertical angles are across from, like in the picture. So remember, vertical angles are congruent. So in this picture, remember x is 50, because these two angles are the same size and the other angles were the same size as each other. Remember, we also had other vocabulary. We had complementary and supplementary, and in my class I showed a little reminder. Remember, the beginning of complementary can be turned into 90 degrees, and if you're really creative, supplementary can be turned into 180 degrees at the beginning. So two angles that are complementary add up to 90, two angles that are supplementary add up to 180 or make a straight angle. So vocabulary-wise, we need to remember that we know these two words parallel and perpendicular. So parallel means that they are never ever going to intersect. So like in this picture here, these lines are parallel. And when they do intersect at a very specific angle at 90 degrees, like over here, those are called perpendicular. So to this, we're going to be adding a new word. A line that intersects two or more lines is called a transversal. When parallel lines are cut by a transversal, several pairs of congruent angles are formed. So in this picture, we have a pair of parallel lines. So P and Q are parallel to each other. We can even use a special symbol for that. P is parallel to Q, and then line T is called their transversal. And this construction has a lot of interesting properties. So when a transversal intersects parallel lines, corresponding angles are congruent. We just used the word corresponding when we were talking about similar figures. And looking at the picture, notice that where they have each angle that has the same number of arcs and the same color in this picture, those would be called corresponding. And we'll talk more about that as we continue. So in this example, we are trying to take what we know that this angle over here is 110 degrees and figure out what angles 1 and 2 are equal to. So the first thing you have to recognize is that this 110 degree angle and angle 1 are corresponding angles. So that means that the measure of angle 1 is the same, so that's also 110 degrees. Then you need to see that angle 2 is complementary to angle 1. So remember that complementary means they add up to 180. So angle 2, let's call that x, plus our 110 degree angle have to add up to 180 degrees. Solve for x. Therefore, x has to be 70 degrees. So angle 2 is 70 degrees. Okay, your turn. You give it a try. We've got a similar picture here. We've got parallel lines L and M. Remember, these little arrows here are telling us that these two lines are parallel to each other. Our transversal is T. Take a minute, pause the video, figure out what the measures of angle 1 and angle 2 are. And here your answer is angle 1 is 63 because it corresponds to the known 63 degree angle. Angle 2 has to be 117 degrees because it is the complement of the 63 degree angle. So 180 minus the 63 gives us that 117. Okay, so now we have this picture where we've got parallel lines cut by a transversal. We only know one angle, this 75 degree angle over here, and we have to find all the other angles. So we need to be able to justify where we get all these angle measurements from. So first, let's start with the other angles that are going to be the same as 75. So first, let's start with angle 1. Angle 1's relationship to the 75-degree angle is that they are vertical. So angle 1 is vertical to the 75-degree angle. So angle 1 has to be 75 degrees. Next, let's take a look at angle 6. Angle 6, it's matching. It's if you took this whole picture over here and dropped it down on top of that picture, 75 degree and the 6 degree, so the 75 degree angle and angle 6 would be right on top of each other. So that makes them corresponding. So angle 6 corresponds to the 75 degree angle. That makes angle 6 75 degrees as well. Okay, then angle 4, I'd probably say angle 4 is vertical to angle 6, which makes it the same measure as angle 6. So angle 4 is also 75 degrees. And we can use similar logic for the other 4 angles, but we have to start with either angle 2 or 3. So let's start with angle 2. So I can see that angle 2 is supplementary to the 75 degree angle. And we know supplementary means adds up to 180. So if let's say that the measure of angle 2 is x, so we'd know x plus 75 has to add up to 180. Solve for x would be 105 degrees. So that means that angle 2 has to be 105 degrees. I'll write that in over here. Then we can figure out the rest of the angles. So angle 3 is vertical to angle 2. So that makes angle 3 also 105 degrees because vertical angles are congruent. So this is 105. And then angle 5 corresponds to angle 2. So that makes angle 5 also 105 degrees. And lastly, angle 7 is going to, you could either say it corresponds to angle 3 or that it's vertical to angle 5. Let's go corresponding. So angle 7 corresponds to angle 3. That makes angle 7 105 degrees. So a big part of this section is really just vocabulary. So this is saying when 2 parallel lines are cut by a transversal, you get 4 interior angles formed on the inside. So think about the inside of a house would be called its interior. So this section in here, all these angles here, 3, 4, 5, and 6 are called interior angles. And then on the outside, the angles out here, so 7, 8, 1, and 2 are called exterior. Like the outside of a house is called its exterior. So the reason we worry about this vocabulary is it gives us a big shortcut rather than having to worry as much about all those corresponding and vertical angle rules. We have some shortcuts because when a transversal intersects parallel lines, the alternate interior angles are congruent and the alternate exterior angles are congruent. So you end up with sort of a shortcut to get from an angle like this one here to that one there, and you don't have to jump and say, oh, look, vertical and corresponding. Instead of having 2 jumps to get from one angle to the other, you can make one bigger jump with just this phrase, alternate exterior. So just in learning this vocabulary, we have a overhead shot of Logan Airport in Boston, and you can see that we have two parallel runways, A and B, cut by another runway. This runway is formed by the blue line, which I haven't named, but this blue line is the transversal. And it's asking us, what's the relationship called between angle 3 and angle 5? And I take a look at angle 3 and angle 5, and I see that first, are they inside or outside the parallel lines? They're inside, and I notice that they're sort of opposite each other. So they're opposite each other, they're the same size. They're called alternate interior angles. And then the next question is saying, hey, take a look at angle 4, take a look at angle 6, and what are those called? And those are on the outside of the parallel lines. They're the same size. They're called alternate exterior angles. And just that vocabulary that we're using is enough to justify that they're the same size as each other. Okay, so now it's your turn to practice. Your assignment is page 531, 7 through 9, 12, 13, 16, 31 through 35. It jumps around a little bit. Tried to select the right problems for you. Give it a go, and I will talk to you later.